What is neuroplasticity? This word is bandied around to describe and explain many things, so let's take a look. Your brain was installed with about 90 billion neurons, little switches, perhaps even binary, that are useless until interconnected. They are connected when the arms from one reach out toward others. The ends of the arms of separate neurons connect through a teeny gap called a synapse. Once they connect, they either stay connected or that connection fades to make way for another. Everything is coded through these electric circuits: thoughts, movements, perceptions, and even sensations below the level of perception. For example, the letter A has a pattern that fits into a larger pattern of alphabet, which fits into an even larger pattern of language, which is deeply seated in the circuits. When you hear a word starting with A, your brain fills in the remaining letters as they come in, to form a word, just like a search engine. Prediction is an instantaneous process for language and everything else in the brain. We have wetware that builds a library of responses fast and automatically. The young brain is filled by age 2 and then starts to assess new information based solely on repetition, like native language. Unless a language is introduced before age 4, the critical period for language, any additional language is linked to the concepts and phonemes of the primary. Until age 7, the developing brain is very plastic, that means neuroplastic. It is designed to establish fresh circuits fast. If those circuits continue to be used, they will approach being hardwired. With repeated use, a myelin sheath will grow to protect them, making that circuit highly resistant to change. This animation is what neuroplasticity actually looks like on a neuronal level. There is an existing path or response firing, connecting a circuit of neurons. The neuronal paths, except for autonomic functions, rest unless used. Though individual neurons serve thousands, if not millions of circuits. This circuit is challenged with a different alternative and reaches out to a new neuron or path of neurons. Ultimately, the new path works and takes over the circuit for that function. That's how it works. Times millions or billions, depending on the complexity of the response. Establishing the first path is easy and automatic, but changing it requires effort, and once established, it must remain the choice or it too will change. The reality of our wiring and personality is that we are binary machines. We assess everything and give it a valence or value. Howsoever small, everything is graded good or bad, and we go toward it or avoid it.